Okay, so now we know what's the model. The seller wants to find a pricing metric and solve those pricing problems. Now let's solve those pricing problems and finally do a comparison. So, okay, we need to use backward induction anyway. So let's look at the stage 4 problem for the consumer. Suppose this consumer has chosen a contract in stage 3. Here, he has bought the amount of minutes with this payment. Then in stage 4, the consumer needs to determine a bandwidth to maximize his net utility, which is the utility minus the payment. Okay. For some reasons we know we only need to worry about the first part. Okay. Afterwards, after we solve those problems, you are going to see that indeed, the first part, this functional form will be what we really need to use for utility functions. Okay. And here I'm saying that we know a utility function has 4 possibilities depending on whether Bm is smaller or larger than theta, whether B is smaller or larger than theta. Okay, here it should be this one that is of interest. Okay, as a consumer, I choose B to maximize this. How should I do that? First order condition, because this is nothing but a quadratic function. Okay, so I do a first order condition for these terms. This is a constant, blah blah blah. If you do all those things, you're going to get this. Okay, interestingly, it's a product between your type theta and something that is a function of the amount of minutes you have. Okay, with that in mind, the effective utility of choosing this particular contract can be found by plugging B into the utility function. So if we do this plugging, then after some straightforward arithmetics, we can get this. Sorry. So again, it's still some kind of product form. The first part is a function of theta, and the second part is a function of the amount of minutes we have. Okay, this will be the utility function for a type theta consumer to pretend to be of type theta hat. And then we say we know in equilibrium they will tell the truth. So let's denote this of theta, the single parameter function, as the equilibrium of telling the truth. But don't forget that because a consumer has the option to deny a contract, so this will be either telling the truth or 0. If I feel that telling the truth is not good enough, then I'm going to walk away without buying anything. I get utility 0. Okay, so that's something we need to have. So in stage 2, the seller solved this problem. I'm choosing a minute function and a payment function so that for each consumer of type theta, telling the truth is better than pretending to be another type. And also telling the truth gives you a non-negative payment. Okay? Now, it may be the case that actually in the previous slides you see we define U as some kind of function, a maximization function. Yeah, actually that's one way. Another way is you just forget that part. And then it's still possible for you to satisfy everything here as long as you set both M and P to be 0. Anyway, we have IC, we have IR constraints. I want to maximize my expected revenue. And that's exactly all the payments I can get from all the consumers. Here, because I have no cost, so there is no cost term in my objective function. I just want to maximize my expected utility total payment. Okay, somehow I need to find a way to solve this problem. Eventually, we can show you that the standard technique should still be applied. And also, if we apply some more recent results that we did not have time to introduce to you in this course, the answer can be found more easily. Anyway, yeah, trust me, we can solve the problem. And the result is here. It turns out that a fixed fee pricing plan is optimal. Oh, this is somewhat interesting. Previously, when you see any kind of continuous type problem, you do not see a fixed fee pricing, right? You always see, for example, monotonicity. Different consumers should be induced to choose different amount of consumptions and pay different money, right? So previously, we always see a nonlinear function for consumption and payments. But here, the optimal solution turns out to be a fixed fee pricing plan. When we price by minutes, the optimal solution is to charge a single fee 4/9, and each one of them can get an unlimited usage. In this case, the seller's expected revenue will be 4/27. Some discussions here. Suppose, as a consumer, I buy this unlimited time usage, then my utility would be this one. Why? Because when I buy unlimited time usage, my utility function will fall into this category because my consumption is so large, right? And then in this case, all I care about is whether my type is high enough to cover for the cost. So I know I will buy this service if and only if my type is high enough. So the seller will maximize the expected revenue, which is the price times the amount of demand, which is 1 minus square root of the price. In this case, price discrimination is suboptimal. Price discrimination means for different usage, charge them different prices. But here, eventually, the optimal solution is to not to do price discrimination. And we say the seller does not screen consumers, right? Because now I only offer a single contract. No matter what did you choose, no matter how did you select, I cannot tell what's your type. The only thing I can do is that, if you really buy it, then your type is higher than this amount. But if you do not buy it, then I know your type is small, but I don't know what exactly it is. Okay, so that's the idea. That's what we mean by does not screen. Okay, suppose I do pricing by bandwidth. So let's see what's going on here. Suppose I design a contract by providing different connection speeds with different prices. Type theta consumer choose another contract that is intended for another consumer. Then the consumer needs to determine the time usage M to maximize this. In this case, M will appear only in the first part, right? If you go back to 2 pages from here, then you're going to see that when one is priced by minutes, he will adjust the bandwidth, and the bandwidth will affect all these 4 terms. But when he is priced by bandwidth and can only adjust minutes, minutes only appears in the first 2 terms or the first part, quantity. The consumer will solve this problem, and the optimal solution would be this one, depending on theta and the bandwidth B. And then the effective utility will become this, okay? Depending on your type, depending on the product of the type and the bandwidth, and something that you cannot control. Again, we care about what's the equilibrium effective utility for a consumer if he tells the truth. The seller need to design bandwidth, payments to satisfy ICR constraint and maximize the expected revenue. In this case, the optimal solution goes back to what we are more familiar with. It is a multi-tiered pricing or usage-based pricing. That means I'm going to design many different options, many different speeds for you to choose. but for different speeds, you need to pay different money. So the optimal solution is the following. The speed is a function 2 theta minus 1. Okay, naturally we can see this is increasing in theta. Also, the price is the following. Okay, here, this part and this part, they are both constants. So let's see what's this. Theta can be found as a particular number. Theta lower bar. Theta lower bar is the lowest type of consumer that is served. So I look at all those consumers and then I realize for those consumers whose type is too small, it's not profitable to serve any of them. So I will only serve for consumers whose type is above theta lower bar. So for others, the bandwidth and the price will just be 0. Okay? And then for those guys whose type is high enough, I design this increasing function and increasing function for them. The expected revenue can also be found. We can verify that we have monotonicity because B is non-decreasing. Also, there's no rent at the bottom because 0, 0, no rent. Efficiency at top can also be found. If you are asking who will get the efficient results, the efficient bandwidth, as we mentioned, is theta, right? So who can get the efficient bandwidth? Only the one of the highest type. In this case, price discrimination is optimal, though some consumers are not served. And one last thing that is interesting is that we see that we are offering a quantity discount. Why? B is linear. Okay, B is linear. The bandwidth offer is a linear function of types. But PB, the payment, is strictly concave. So that means if you get twice faster bandwidth, okay, then you are not going to pay twice more. Okay, you get some quantity discount because the payment function is somewhat strictly concave. Okay, so that's something we found when we price by bandwidth. We also want to solve for the result for pricing by quantity. First, again, we need to solve the after-sales selection problem. In this case, I choose a quantity and a payment, and I can now modify M or B or both. But anyway, because B times M must be Q, is equivalent for any kinds of modification. So let's use B as the variable here. In this case, B will only appear in the second part here, right? Because Q has been fixed. So this case is more similar as pricing by bandwidth, right? Because the after sales selection can only affect one part, but for pricing by minutes, it can affect two parts. The consumer can solve this problem by setting the optimal bandwidth data, and then the effective utility can also be found. We define the same thing. We solve the same problem. Okay, again, ICIR expected revenue. Again, the optimal solution is a multi-tiered pricing plan. As we mentioned, pricing by quantity is similar to pricing by bandwidth because the after-sales selection affects one part. They are different from pricing by minutes because in pricing by minutes, the after-sales selection affects two parts. Okay, so under pricing by quantity, we see the solution is again something similar. There is a theta lower bar. Below it, the offer is 0. Above it, the offer is an increasing function for quantity and the payment. Okay, we also have the expected sales revenue. And then, if we look at it more carefully, we can see that the results are just identical. It's not similar, it's identical. Identical to pricing by bandwidth. Okay, this thing is very similar. Exactly the same. This is exactly the same. This is the same. Actually, this is the same. Why? If we look at the consumer's effective utility, when we price by bandwidth, it will be something like this. If we price by quantity, it's something like that. If you do a mapping between variables, you see consumers get exactly the same thing when you are solving the problem. That means you are solving the same problem. Okay? And that's not surprising that you get the same results. Okay, so now we have all those stage 2 solutions. We are able to solve the stage 1 problem. So now let's select the best pricing metrics. After some, the first part is the summary. A single contract is offered under pricing by minute. A menu is offered under pricing by bandwidth or quantity. Yeah, something you have seen. And then for pi according to minutes is the least compared to the price and the profit according to bandwidth and the profit according to quantity. Okay, so pricing by minutes is not revenue maximizing. The other two is. Also, if we compare about the demand, which depends on 2 over 3 and the data lower bar, we can see that more consumers are served under pricing by bandwidth or quantity. And afterwards, we see that pricing by bandwidth and pricing by quantity, they are just equivalent, or I should say they are just identical, right? So these are some insights we found in solving our simplified model. In particular, you may choose either pricing by bandwidth or pricing by quantity because they are optimal. So now we want to ask why, from the perspective of information. Pricing by minutes cannot screen consumers, right? That's something we have found. Under pricing by minutes, you offer a single contract. That means when you use minutes as the pricing variable, you cannot screen consumers. Even though you know consumers have hidden types, even though you try to design a menu of contract, still the best thing to do is to offer all of them unlimited usage, is to offer them a unit price. Okay, so that means you cannot or you should not screen consumers. Also, pricing by minutes is the least effective in alleviating the moral hazard problem. What does that mean? Moral hazard problem comes from the fact that consumers can do after-sales selection, and we care about how large is the room for consumers to do the adjustment or to do the selection. If we use pricing by minutes, then consumers are too free. Why? In that case, consumers adjust bandwidth, and the bandwidth is going to affect both bandwidth and quantity when minutes are fixed. But in the other two cases, only one part can be adjusted. If you fix bandwidth, adjusting minutes only affect quantity. If you fix quantity, then adjusting whatever only affects bandwidth. Okay? So when you do pricing by minutes, consumers are the freest, and you are giving them the highest flexibility to do whatever they like. Or we can say they are in the most uncontrollable situation. So that means the moral hazard problem is somewhat the most serious. So now we know why pricing by minutes is not preferred by the seller. From the information's perspective, this is not helpful for the adverse selection problem. And also, it is the least effective for the moral hazard problem. So that's why pricing by minutes is not a good idea, because of these information asymmetry problems. Okay, so that's the main idea, but we want to ask, Are those ideas really true? Are those insights robust? If we have a more general problem or a more general model, will we always see pricing by minutes inferior? Or pricing by bandwidth and pricing by quantity, will they always be identical? We want to ask these questions so that we can, we need to answer these questions so that our research or our study becomes more valuable or contributive. So we need a more general model, and essentially that's the original model proposed in the paper. Thank you.